Hi everyone and welcome back to the channel. In this series, we'll cover the topic of generics in TypeScript, and we'll begin by writing some generic functions. But before we get into that, let's firstly see where the need for generics comes from. Let's imagine that we want to write a very simple function that accepts a string value as an argument and returns an array with that value. It might seem silly at first, but in some cases we might want to have some additional validation or more complex logic, so we can use that function as an example. So I'll write a function, I'll call it wrap string in array. It will accept one string value, and the return type will be a string array, right? And it will have exactly one element inside of it. So this was the more TypeScriptish part. Inside of it, I'll just say return an array. I'm using the square brackets as the syntax for an array. And inside of it, I just want to plug in the value. So that means that if we receive a string with text pencil, we should return an array with that element pencil. And we can actually give it a go. We can call the function, or we can even store the result in a variable. So let's say const array1 equals. And now I will call this function, and I'll pass in pencil as a parameter. If I hover over this, I can see that the return type is clearly an array of strings, and that's what we would expect, right? Because that's what we stated up in the function definition. So that seems to be all right. And of course, if we want to, we can start working with the element inside of this array. And if I use the dot operator, I can see that I have access to all of the string methods because this is an array of strings. Therefore, its element is also a string. That all makes sense, right? There's nothing new here. But what if now we want to create a similar function, but we want it to work with numbers? So it accepts a numeric value and it returns an array with that number inside. How can we do that? Well, one thing we could do is we could just copy the function, call it wrap num or number in array, change the type of the parameter and the return type. So number, array number, and voila, now we can use it. We can say const array2 equals wrap number in array. We can pass in, for instance, 45, and of course we can see that the return type would be an array of numbers, and we can log this result just so that you can see it. There we go. So we have the number wrapped inside of an array. All right, so far so good. What if we want to extend this functionality and make it also work for Booleans? Would we have to make a third function? This gets kind of annoying, doesn't it? So how can we write our code in a way that we only mention the logic once, but we make it work for different types of parameters? Now, your first idea might be, well, maybe we can use the any type. But I've already told you that the any type is kind of meaningless. It's definitely not a good practice to use it. So we could give it a go. So we say that we accept a value of type any and we return an array of any. And now I just need to rename the method. It would just be wrap in array. Or wrap value in array, like this. Fix the name in the function calls, and now this seems to be working, right? But what happens if I hover over the array variables? Well, we see that both of them are arrays of any, which is expected, but now what if we want to work with the values inside? We can't really use any methods. I have basically disabled the TypeScript type checks, which kind of makes it useless to even use TypeScript in the first place, because now I can do all sorts of wild things. For example, we could try to use the element inside of array 1. So we can basically take pencil and try to use to fixed or something like that, which is crazy, right? But because we basically disabled the TypeScript checks, we can actually do this, and we are going to receive a runtime error. Let me just show you. So I can say array 1, index 0 in order to plug out the value, and I can say to fixed 3, whatever. And I can try executing this, and of course I'll get an error because I cannot really apply to fixed on a string argument. So this is clearly not a good practice. Just imagine working on a greater project with many files and functions. This is going to get extremely messy. So is there a middle ground? Because now we saw the two extremes. Is there some sort of a resolution to this conflict? Well, there is, and it comes with generics. So here's how generics work. At first, it's going to seem weird, but I'm going to explain it slowly, and hopefully you get the idea. The first thing is the syntax that we got to lay out. So the way we do it is after the name of the function, we write angle brackets, and inside of them, we write our kind of own name for the unknown type that we're going to get. So I can call it anything. We could call it value type or element type. Very often, you see just a letter, for example, T for type, and then UV, etc. For now, I'll leave it as a value type. Now, this seems a little bit out of context, like what am I going to be using this for? I'm going to be using this for now as a placeholder type, and I'm going to mention it anytime I have the any, right? So I want the function to accept a value of a given type. I still don't really know what it's going to be, but there's going to be a certain type, and it's going to return an array of the same currently unknown type. And again, how does that help? Well, look at how this works. So once I call the function and I pass in an argument, this argument is going to be the value, right? What is the value type? Well, this is type string, right? So in this first case, our value type will basically be a string. And this means that the function will accept a value of type string, and it's going to return an array of string. In the second function call, however, it's different, right? Because we passed in 45 as a value. Therefore, its type will be a number. So this whole generic function will work with numbers strictly. And the return type will also be an array of numbers. And if I now hover over the arrays, we can see that the first one is an array of strings. The second one is an array of numbers. And that's much better. And now look at what happened when I tried to apply to fixed to the string. TypeScript is now complaining, which is actually great, right? It's complaining that the method to fix does not exist on type string. But if I use the dot operator, I can actually now see all of the possible string methods because I have properly used the types in this scenario. So that's the idea of generics in functions. Now I'll go back to the T letter just because you have to get used to it. I know it looks more scary and confusing when it's just T, but this is just a placeholder for type. And then whatever type you pass into your function, this is going to be your whole generic type. In this case, it's going to be a string everywhere. In the second case, it's going to be a number everywhere, right? Now, let's expand upon this example. Let's imagine that we want to accept two values of the same type and return an array with both of them. So I could say that I receive value 1 of type T and value 2 of type T. And then the return will have an array with value 1 and value 2, right? And the only thing left to fix is the function calls. So now I need to pass two values each time. And they have to be of the same type, right? So for instance, for Pencho, I can also add Penka. And for the numeric values, along with 45, I can pass -10. It doesn't really matter. It just needs to be of the same type. Is this going to work? Absolutely. We can print, I don't know, just array 1. We can also print array 2. We can print array 1, index 0, and now we can apply all of the string methods because we have used types properly. And we can do all kinds of cool stuff. But then there's another question that comes up. What if I want the two values to be of different types? And I don't initially know what they will be, but I want to allow for different types. Well, that's easy to fix. We can actually just introduce a second type parameter inside of our generic. So we'll say, in addition to T, we also have another type. Let's call it U. And now I want to say that value 1 will be of type T, value 2 will be of type U, and they could be different. Now, this introduces a slight issue that I'll talk about later, but for now, let me just modify my function calls a little bit. Let's say that in the first one, I'll pass a string and then a number. In the second one, I'll pass a number and then a boolean. That works, right? The only difference is that I'll have to also fix the return type. So I receive two values of different types, right? For example, a string and a number, or a number and a boolean, or any other combination that you can think of. Therefore, the return value will not be an array anymore, right? An array has to have the same types inside of it. Now we have two different types. Therefore, we return a tuple, or a tuple, depending on the pronunciation. But I can say that I'll have a tuple with the first element being of type T, right? Because value 1 is of type T. And then the second element will be of type U. Okay, and now this is going to work perfectly fine. So how does this work? Well, the first time we pass Pencho, this will be the value 1. Therefore, the type T will be string, right? The second argument that I'm passing, let me just change the color, is -10, which will be value 2. Therefore, the type U will be a number. So this function works with two generic types, T and U. In this particular function call, T will be string, U will be number. And then, therefore, we return a tuple with the first element being a string, the second element being a number. But the cool thing about generics is that the second time I call the function, I can use different types, right? In this case, value 1, so T will be a number, and value 2 is of type Boolean, so U will be Boolean. And then you can test it with other combinations as well. So this is how you can write generic functions in TypeScript. I hope the video was helpful, and if you have any questions, don't hesitate to share them in the comment section. See you in the next tutorial.